Before we can flip and multiply, however, this needs to be combined into a single fraction. So when you are dealing with complex fractions, look at the top, look at the bottom, get them into one single fraction on top, one single fraction on the bottom. So how do we get this into one single fraction? So we have a subtraction. In order to subtract, they have to have a common denominator. And what would their common denominator be? So if we multiply the bottom by y, we have to multiply the top by y. So we have 2 over x divided by, go across the top, y, subtract 1 over y. So fraction on top, fraction on the bottom. Then we can flip the fraction that's on the bottom and multiply. Multiply across, look if you can cross reduce, which we can't. Multiply across the top, we get 2 times y. Multiply across the bottom, we get x times y minus 1. Same process in the next one. We have to get the numerator into one single fraction. In order to do that, we need a common denominator of x. So on the top, I would have 3x minus 3 over x. In the denominator, I have a 1/2 and I have a 1 over x. So what's my common denominator going to be? 2x. So this fraction needs an x. This fraction needs a 2. So I have x minus 2 over 2x. Once we have a single fraction over a single fraction, we are going to take the fraction on the bottom and flip it and multiply. Anyone notice anything about this right here? The 3x minus 3. I can take a 3 out. It doesn't actually help us in this specific problem, but we should still be in the habit of trying to factor. So this is 3 times x minus 1. I say it doesn't help us because we can't cancel anything anyway, but still good to be in the habit. So multiply across the top. I have a 3 times a 2x. So 6x, and then I have an x minus 1. And then I have an x and an x minus 2. Now, is there anything I can cancel? Okay, those x's can cancel. We could have canceled them here. I missed it. So we have 6 times x minus 1 over x minus 2. So if we look at 16, what's the first thing that we do with this? Factor. So x squared plus 7x plus 12. It has an x squared, it has an x, it has a number. So we look for 2 numbers that multiply to 12 and add to 7. Okay. So x plus 3 and x plus 4. X squared minus 9, perfect square minus perfect square. That is also going to factor. Numbers that multiply to 9 are 3 and negative 3. So we have x plus 3 times x plus 4 divided by x plus 3 times x minus 3. X plus 3's can cancel. So we have x plus 4 over x minus 3. Now, the directions on 16, 17, 18, and 19 say to state the restrictions on the variable. So if we look at our factored form of the denominator, x plus 3 means that x can't equal negative 3. X minus 3 means that x can't equal 3. $17 is actually already factored for you. But if it wasn't factored, that's where you'd want to start. Since it's division, we are going to take the second fraction and flip it. So x plus 3, 2x minus 1, x plus 4, x. Anytime you have a negative x inside parentheses, let's change that. Okay. So the way that we change that is to move the negative out front, which is going to change both signs of the inside stuff. Okay. So now I'm going to look for stuff that I can cancel. I can cancel the x's. I can cancel the x plus 3's. 2x minus 1, 2x plus 1, those don't cancel. X plus 4 doesn't cancel with anything. So I have a 2x minus 1 over a negative somewhere, off top or bottom, it doesn't matter. X plus 4 times 2x plus 1. Now, on a division problem, we have to look at the denominators of our original fraction, So we have an x by itself, which means x can't equal 0. We have an x plus 4, which means x can't equal negative 4. And we look at when we flip it, we also look at this denominator. So x can't equal negative 3, and x cannot equal negative 1 divided by 2. So we put this number over this number. So those would be our restrictions on the variable for 17.